We're going to engage ourselves in a course titled Sampling and Data Management in Healthcare System. Sampling and Data Management in Healthcare System. In the chapter 1 of this material, we'll be talking about statistics. As healthcare managers, you need to know, if not much, at least we need to know a bit about statistics in our paramedical functions. So statistics refers to a branch of mathematics that is concerned with the description and analysis of data. It refers to a branch of mathematics that is concerned with the description and analysis of data. That is the definition of statistics. So for your level, and as for the fact that you are not engineers or computerists, we will want to limit ourselves to medical aspects of statistics. Knowing fully well, getting the understanding of the definition of statistics, I want to let you know that statistics is classified or divided into two. We have descriptive statistics, we have inferential statistics. Descriptive statistics and inferential statistics. Descriptive statistics summarizes data numerically and graphically. So indirectly, it describes data. Inferential statistics refers to the statistical procedure which allows the researcher to make inference on the entire population based on a sample of the population. I want to repeat, statistics is a branch of mathematics that is concerned with the description and analysis of data. And I said it is classified or divided into two parts. We have the descriptive, we have the inferential statistics. The descriptive statistics summarizes data numerically and graphically. That is to say, it describes data. While inferential statistics refers to the statistical procedure which allows the researcher to make inference on the entire population based on a sample of the population. We want to quickly look at examples of descriptive statistics. Examples of descriptive statistics. We have mean, we have median, we have mode, we have range, we have variance and standard deviation, to limit ourselves to these six. Mean, media, mode, range, variance, and standard deviation. Inferential statistics, examples of inferential statistics. We have some types of inferential statistics. We have the parametric and non-parametric. The parametric and non-parametric. Under the parametric, let me first of all define it before we can give examples of a parametric statistics. Parametric statistics is applicable to data derived from interval scale of measurements. Parametric statistics is applicable to data derived from interval scale of measurements. Example of such statistics, parametric, we can see Pearson product moments, correlation. Then we can see Pearson product moments, correlation coefficients. We can see t-test. We can see ANOVA, which is analysis of variance. We can also see multiple regression. So under the non-parametric, this definition goes thus. Non-parametric statistics is applicable to data derived from ordinal or nominal scale of measurements. Examples of these are chi-square, Spearman rank order correlation, sign test, median test, and so on like that. So I want to quickly go back to another form of statistics that we call biostatistics. Biostatistics has entered into play because it refers to the application of statistics to the biological sciences and medicine. Biostatistics refers to the application of statistics to the biological sciences and medicine. The techniques are identical to those used in statistics, although there is greater focus on measures of impact, such as relative risk and odds ratios. To really explain further, we want to know what really is biostatistics. It is the branch of statistics responsible for interpreting the scientific data that is generated in the earth sciences. It is a branch of statistics responsible for interpreting the scientific data that is generated in the earth sciences, including the public earth sphere. All I have said under descriptive and inferential statistics, I'm still coming back to explain them one by one. But I want us to quickly get some information on biostatistics. Like I said, biostatistics is the branch of statistics responsible for interpreting the scientific data that is generated in the earth sciences, including the public earth sphere. Biostatistics is integral to the advancement of knowledge, not only in public health policy. It is integral to the advancement of knowledge, not only in public health policy. What are the roles? We have people that we call biostatisticians. Biostatisticians, people that engage themselves in the work of biostatistics. So we want to know their roles as biostatisticians. So biostatisticians are said to be specialists of data evaluation, and the work of biostatisticians is also required in government agencies and legislative offices, where research is often used to influence changes at the policy-making level. So, I want to start mentioning the roles that they play in their duties. Number one of those roles is clinical trials. Clinical trials. What do I mean by this? They are involved in studying the evaluation of treatments, screening, and prevention methods in populations. Studying the evaluation of treatments, screening, and prevention methods in populations. So clinical trials is one of the roles they play as biostatisticians. Number two, epidemiological. Epidemiological. Studying the causes and origins of disease in the human body. They are involved in studying the causes and origins of disease in the human body. That's why we term it epidemiological. Then again, we have human genetics. Human genetics. That is, they get involved in studying the genetic differences associated with diseases and disease states. Studying the genetic differences associated with diseases and disease states. Another point is genomics. This one studies the biological activity of genes as they relate to diseases and treatments. When we say genomics, that means they are involved in studying the biological activity of genes as they relate to disease and treatments. We also have what we call spatial studies. Spatial studies, S-P-A-T-I-A-L, spatial studies. That is, they are involved in studying the geographical distribution of disease and risk factors. They are involved in studying the geographical distribution of disease and risk factor. They are also involved in designing and conducting experiments related to health. They are involved in designing and conducting experiments related to health. They are also involved in collecting and analyzing data to improve current public health programs and identify problems and solutions in the public health sector. Let me explain the two. Designing and conducting experiments related to health. Of course, in the field of health, we are bound to conduct experiments We are bound to carry out investigations on a daily basis. And these are part of the roles played by biostatisticians. I made mention of collecting and analyzing data to improve current public health programs and identify problems and solutions in the public health sector. Of course, they must collect data, they must analyze data if public health programs are to be improved. And if we really want to get solution to problems identified, we need to collect and analyze data. The last point here, making it 8 points that I'm giving out under the role of biostatisticians. They have to understand the facts that they need to interpret the results of their findings. They must interpret the results of their findings. So this will now take me back to descriptive and inferential statistics, the examples I made mention of. Mean is a mathematical average of terms. Add up is just a way of adding up all the values and dividing it by the total number of values in a set of data. It's a mathematical average of all terms, and it's a way of adding up all values and dividing the total and divide by the total number of values in a set of data. Like for example, let me give a very simple set of data, 2, 4, and 6. All you need to do in this case is add up 2 plus 4 plus 6, that is 12. Divide by the number of observations, the number of values in the set of data. How many? What is the number of values in the set of data now? It's just 3, 2, 4, and 6. That is 12 over 3. That will give you 4. Okay? So 2, 4, and 6 divide by 3 gives you 4, which means your mean in that set of data is 4. Now let's go to median. Median is the observation that falls in the middle of the variable distribution. Median is the observation that falls in the middle of the variable distribution. It can be odd and it can be even, depending on the set of data given. Let me take one as an example now, where we are having 1, 2, 3, 4, and 5. And let me scatter it. Let me say 5, 3, 4, 1, 2. All you need to do when you want to get your your median, is to rearrange. And then you make it 1, 2, 3, 4, and 5. So what are we talking about? By the time you arrange, you want to check the value that is in the middle. If I were you, I would just pick 1 and 2, then pick 4 and 5. What remains in the middle is 3, which means your median is 3. But in a situation where we have 6 values in a set of data, Like for example, the way I scattered it, let's say 6, 4, 3, 5, 1, 2, and you arrange it to be 1, 2, 3, 4, 5, 6, and you want to find your mean, that is in an even way now. You want to check the middle, the value in the middle now. By the time you remove 1 and 2, you remove 5 and 6, you are left with 3 and 4 in the middle, which means you will need to add up 3 and 4 over 2 to get your median. So 3 plus 4 makes 7, and that's 7 over 2. That is 3.5. So which means your median is 3.5. That is telling you, I have given an example in a situation where you have odd number, and in a situation we have even numbers in the middle of your values. I believe we are done with median, with the explanation. The mode is the most frequently occurred value of the terms in a set of data. Values that occurs most frequently. Like for example, let me quickly use a very simple example that you will understand. In a set of data like this, let's say we are having 2, 3, 3, 3, 4. 2, 3, 3, 3, 4. I can also scatter it and make it 4, 3, 3, 2, 3. So by the time you arrange it, you will come to realize that your mode is 3, because it is 3 is most frequently used there in the set of data. So in a situation where you are now rearranging to now get 2, 3, 3, 3, 4. 3 is your mode. I want to give us some idea, which may not be very common anyway. We have what we call Bi-Modal and Tri-Modal. Bi-Modal is a distribution with 2 modes, and Tri-Modal is a distribution with 3 modes. Example of this is where you are having a set of data and you want to get the one that is frequently used. You are likely to see 2, 4, and 7 having the same number of frequency. That is a trimodal type of mode, which means where you are having 3 value frequently used. That means you will add the 3 together and divide by 3 to get your mode. Where you are having 2 values frequently used, if it is 2 and 4 that is frequently used at the same number, then it means you are adding 2 plus 4 over 2 to get your mode. That means you are operating on a bimodal type of mode. And if it is 3, you are operating on a trimodal type of mode, which means if you are asked to explain mode or define mode, let me say explain now. In the process of giving a definition for mode, you must also make reference to these other 2 types of mode, bimodal and trimodal. Then range. Range is just the difference between the maximum and the lowest value in a set of data. The difference between the maximum and the lowest value in a set of data. example of this, let me give us a set of data in this case. Let us assume that in a set of data, we are having 10 as the highest value. And in that same set of data, we are having 3 as the lowest value. That means we are going to subtract 3, which is the lowest, from 10, which is the highest. That means our range will be 7. That means 10 minus 3 is 7. That is range. Now, Now we want to talk about variance. You can define variance. We are still talking about differential statistics. We have made mention of 4 examples, and number 5 example is variance. Number 5 example is variance. Variance is the average of the squared differences from the mean. Average of the squared differences from the mean. You can also say variance can be given as standard deviation squared. But I want to give us a formula as to how to calculate variance in case you have a formula. In case you have an assignment on it. The formula to calculate variance is this. Number 1, you work out the mean. That is, you take the average of whatever values that you are given in a set of data. You calculate the average. Once you get the average, you will then subtract that average from each number in the values in a set data. When you subtract the average from each number in the set data, you will now square the results. Okay? When you square the results, then you also now, by the time you get the overall total, you will now work out the average of those squared differences. You will work out the average of the squared differences. So in a case where you are having, let me stop here for questions because my time is gone. So we'll continue with variance in the next meeting. We'll continue with variance in the next meeting. So I want to give room for question. 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 Question.
Mr. Yorubatson, you guys unmute your speakers. Get to tell the
It is time for question now. Hello? Any question? Some question might tell me go respond. Any question? Get any response?
So, Mr. Yomi, is there anybody there?
Hello, Mr. Yomi. Hello, Mr. Yomi. Well, you get a response. Time, look at it.